Geometry Node is a recent introduction to Blender and opens up a wide opportunity for artists. In this video, I will show you how you can systematically build a geometry node system from scratch using some fundamental mathematical principles. Don't get intimidated by the word mathematical, it's a piece of cake as you will see. Some experience with geometry nodes will help you understand it better. Let's start. I have a scene set up in Blender. I'm using this pine tree model which is distributed over this plane using the point distribute geometry node. The distance from this empty object basically controls sizes of these trees, but I have more control over the effect using these sliders on the right. The radius slider controls the extent of this effect. If I increase this value, the effect goes further. The decay slider controls smoothness at the edge. Now it's a harsh edge. If I increase this value, the edge becomes smoother. The ray slider affects the sizes all over the plane equally, and the amplitude slider affects the trees closer to the empty object more. So let's see how to build this geometry node system from scratch. This graph shows the kind of effect I want. In this graph, x-axis is the distance of the empty object. Y-axis represents sizes of the trees. So as distance grows, the size falls down. I can control different features of this graph using these sliders. For example, this decay slider controls smoothness at the edge. I can use this slider to raise the curve up or down, and I can use this slider to shift the curve left or right, and this slider to add a scaling factor to the curve. Also, we are not interested about left side of this graph as distance is always positive. So how can we come up with this graph? The idea is to start with a function that closely matches the effect we want to create. In this case, it is the tanh function. The first thing to notice is that with tanh, the scale increases with distance, whereas we want it to decrease with distance. So we have to flip the curve along y-axis, and that can be done by multiplying x-axis with -1, which is equivalent to writing -1 over here. Now we don't want our scale to go negative, therefore we have to shift this curve up, and that can be done by adding a constant. Next, we want control over the slope. We can easily do that by scaling x-axis. We also want to control position of the curve in horizontal direction, so we need to add a shift. Finally, we will add a scaling factor to better control height of this curve. At last, we have the equation we need to write our geometry node system. Back in Blender, we are using math nodes to write this equation. We are getting the radius, decay, raise and amplitude inputs from the group input node, and we can select the values using these sliders. The first node needed to write this equation is a vector math node that calculates the distance between this empty object and the points on this plane, and we store the result in an user-defined attribute x. The second node is an attribute math node that subtracts our input radius from x, and the result is stored in xs. Xs is then divided by our decay input and stored in xf. Xf is then multiplied by -1 and we get the quantity inside tanh function. After performing the tanh operation, the result is stored in y tanh. We add the raise input and multiply amplitude, which finally affects the scale attribute. Finally, we have completed our geometry node system. The link to this file is available in description. So here is a question for you. What function will you use to create this effect? Answer in description. Like, comment and give your feedback in comment section. Thank you for watching.